Okay, our time for functional group number 2. So functional group number 2 are alkenes. So alkenes are similar to alkane in that they are still a hydrocarbon, so they still have C and H. The difference now is that they have at least one double bond between the carbon atoms. So we are going to find the general formula for these, right? We talked about general formulas for alkanes. It's still going to have that CN, but now, oh, things aren't going right. So CN, but now it's H, just 2N. So there's no plus 2. So we're going to find that that's going to be the big difference. We're going to have 2 fewer hydrogens, and that's because every double bond that we put in takes away 2 hydrogens, right? So if we had 2 double bonds, we would actually be 4 hydrogens short. If we had 3 double bonds, we'd be 6 hydrogens short, okay? So these are also still considered to be aliphatic. Like I mentioned before, everything's aliphatic until we get into things that are not. Okay, we talked about alkanes as being saturated, and we said alkanes were saturated because everything was a single bond. We find that alkenes are unsaturated. And the reason they're unsaturated is they have that double bond. Okay, so when it comes to naming these, okay, your rules are super similar to what they were for alkanes. So we're still going to have 3 parts. We're still going to have the prefix, we're still going to have the root, we're still going to have the suffix. Each part is still telling us the same information, right? So prefix is still going to tell us the size and location of side chains. The root is still going to tell us how many carbons are in the longest chain. Okay, the only difference when it comes to that root is that the double bond has to be in that longest chain. So that does mean that there are some situations where you could actually make a longer chain, but you can't because the double bond then would be in the side chain. And we don't want the double bond in the side chain. It has to be in the main chain, okay? So our suffix, in this case, right, when we talked about alkanes, the suffix for alkanes was -ane. When we are dealing with alkenes, the suffix is going to be -ene. Okay, the difference though is I need a number with that -ene. Okay, and the reason I need a number with that -ene is I need to know where that double bond goes, right? So just like with our side chains, we put a number with them to tell us where they were, we're going to do the same thing with that double bond. We're going to use a number to tell us what carbon it's after, okay? So if, for example, the double bond was between carbon 2 and 3, we would call it a 2E. If it was between carbon 3 and 4, it would be a 3E. So, okay, the only other thing that changes is our numbering, okay? So we said when we were doing alkanes, we want a number from the side that gives us something at the lowest number. That still holds true. I still want a number from whichever side gives me something at the lowest number. What's slightly different though is if we have a tie, right? So we said before that if we had a tie for the same lowest number, we went alphabetically, right? So we looked at our 2 side chains, we figured out what they were called, and then if like we had an ethyl and a methyl, for example, we chose ethyl because alphabetically it came first. So when we are doing alkenes, you're going to find that we talk about something that we call, make some room here, we call it an order of priority. Okay, and this basically means if I need to decide, such as in the case of a tie, where am I going to go to first, okay? So order of priority is only for a tie, okay? No tie, I don't care about order of priority, I care about what's a smaller number, okay? But if I have a tie, I'm going to follow order of priority. You're going to see that as we go through the lessons, we're always going to add to this list and it's always going to be changing. Okay, but what we find for our order of priority is that now a double bond is first. Then it's our alphabetical side chains. So if the tie for the same number is between side chains, I'm going to go alphabetically. If the tie is between a double bond and a side chain, the double bond is going to win that lowest number, and that's going to determine the direction in which we are going to number. Okay, so looking at a couple examples out of your problem book. So this is number, I want to say it was number 2 out of your alkane sheet. Okay, so our steps are going to look really similar to they did before. We are going to start by determining where our longest chain is, okay? Making sure that the longest chain contains this double bond. So a couple options, we could either go 1, 2, 3, 4, or we could do 1, 2, 3, 4. Doesn't matter which one you do, you're going to wind up with the same name. So let's just go right across the page, okay? So there's our main chain. Okay, we need to number. So 1, 2, I get a double bond right after 2. 1, 2, I get a side chain, and I get a double bond right after 2. So in this case, we have a tie for the same number 2. If we go from the left side, we only have a double bond at 2. If we go from the right side, we get a double bond and a side chain at 2. So that's the option we're going to choose because it results in the lowest set of numbers. Okay, so 1, 2, 3, 4. All right, so prefix. Prefix is the same as it was with alkanes. The prefix is going to describe our side chain. We only have one side chain, the CH3 group, right? This is a methyl. It's attached to carbon number 2. So our prefix is going to be 2-methyl. Okay, there's no other side chain, so that's the only thing to go into the prefix. The next thing we need is the root. So we've already established that there was 4 carbons in our main chain. The name for 4 is bute. Okay, now when we go to do the ending, because we have a double bond right here, that means this belongs to the ene family. So our ending is going to be ene. Whenever we use ene, we need a number to show where it is. So because it's between carbon 2 and 3, we're going to use the smaller number. So we're going to say -2 -ene. Okay, so this is going to be 2-methyl bute 2-ene. Okay, let's look at another one out of your book. This one is number 4, okay? So same steps, find our longest chain. So straight across, we go 1, 2, 3, 4, 5, 6. The only other potential option that could be longer is this one, so we check that. 1, 2, 3, 4, 5, 6. It's also 6, so again, doesn't matter which one we choose. Let's just go straight because it's easier. Okay, so numbering wise, if I start from the left side, this is number 1, this is number 2. I have something at 2. If I number from this side, 1, 2, 3. So because I have a 2 and a 3, I don't care what's where. I literally just care that a 2 is smaller than a 3. So numbering wise, this will be 1, this will be 2, 3, 4, 5, and 6. Okay, so prefix wise, I have 2 things that need to go into my prefix, right? We have this here, which is a methyl, and we have this here, right? Because this one has 2 carbons, it's called ethyl. So when we go to put these into the name, because we have a methyl and an ethyl, we have to put them in alphabetical order. So alphabetically, ethyl comes before methyl. So we're going to have 4-ethyl. Okay, that's telling us that carbon number 4, we have our ethyl. Then we're going to have -2-methyl. Again, because dashes separate numbers from letters. Okay, there's no other side chain, so that's it for my prefix. Now I get my root. So I have 6 carbons in my main chain, so hex. Okay, ending, we have that double bond right here after carbon 2, so 2-ene. Okay, so looking at some that go the other way. So now we have a name, we're being asked to draw a formula. So same pattern that we did with alkanes, we're going to start by finding our root, right? So our root is pent. So the fact that the root is pent tells me that I have 5 carbons, right? So 1, 2, 3, 4, 5. All right, we are told that it is a 2-ene. So again, we're always going to start numbering from the left side when we get to draw this. So there's carbon 1, here's carbon 2. So that means I have a double bond here, right? because that's what an ene is telling me. I don't have any other enes, right? It's not a diene, right? And a diene, if you think about it, would mean that I have 2 double bonds, and it's not a triene, because that would mean that I have 3 double bonds. So because it's just one ene, right, there's no prefix in front of it, there's only one number, that means I'm safe to assume that everything else is a single bond, okay? Other thing we need to do, obviously, is put in our side chains. So it is a 2,4 dimethyl. So that's telling me that a carbon 2, which is this guy here, I need to put a carbon down here, right? And at number 4, I also need to put a carbon, okay? So last thing we need to do, obviously, is fill in those bonds and fill in our H's, right? So this would be a single bond, again, because I don't have any information that it's not a single bond. So this one, okay, we got to fill in those H's. So same as before, every carbon needs 4 bonds, so this is going to be 3 of them. Alignment is not my friend right now. Okay, this carbon has 1, 2, 3, 4 bonds, so that means this carbon gets nothing. It already has what it needs. Okay, this carbon has 1, 2, 3, so it needs 1 H to get it up to 4. Okay, this carbon has 1, 2, 3, so it gets 1 H to get it to 4. This one gets 3 to get it to 4. And then same deal here. This one's also going to get 3. And this one is also going to get 3, right? So now we have a 2,4 dimethyl pent, because 1, 2, 3, 4, 5, 2 ene, because we have that double bond hanging out right there. Okay, this one, number 8, methylpropene. A lot of times you guys look at this and you're like, that can't be right. There's no numbers. So why this one has no numbers? It doesn't need a number. And the reason it doesn't need a number is there's only one spot to put everything. Okay, so whenever there's only one spot to put something, you technically don't need a number, because the point of the number is so that you're not left guessing where something goes. So same as always, start with your root. It's prop. So there's 3 carbons. 1, 2, 3. So it's an ene. That means I have a double bond. So why I don't need a number? If I put the double bond over here, this is carbon 1, so it would be a prop 1e. If I put it over here, then I would start numbering over here, and this would be 1. So it would be the exact same thing, right? The other way to think of it is it would just be a rotated image of itself. If something's just a rotated image, then it's the same. So you can honestly choose either spot to place that double bond. It doesn't matter. The other one's going to be a single. Okay, then we have a side chain of methyl. Again, sometimes it's like, well, there's no numbers. How do I know where to put it? Well, we said you can never put it on the first one, and you can never put it on the last one, because then it's actually part of the main chain. That means only one spot for it. That's right here in the middle, right? So that's why this has no numbers, because it doesn't actually need numbers. There's only one way to draw it. Normally we need numbers because there's more than one spot we could put something. So still need to fill in our H's. This has a double bond, so it needs 2 H's to fill in those gaps. This middle carbon already has 1, 2, 3, 4. It doesn't need anything else. This one only has 1 bond, so it needs 3 to fill it up. And same with this guy. Okay, and there's your methylpropene. All right, so physical properties of alkenes. Super similar to alkanes. The reason they're super similar, they're still nonpolar. The only intermolecular force they have is London dispersion forces, okay? So what that means is melting boiling point wise, they're going to follow the same trend that we saw the other ones follow, okay? They're going to have that same upward pattern to them. When we talk solubility, we're going to find that these are soluble in hexane. And that's simply because they're like dissolves like, and so they are going to dissolve in that as well. So if you think about the melting point and boiling point, we talked about alkenes the other day. We said they followed this pattern. What you're going to find is alkenes follow the exact same pattern, except they're going to be lower They're going to be lower because they have fewer electrons.